Thank you very much for the invitation to be here. It's a pleasure to talk a little bit about my PhD project that's about cystic fibrosis, and especially in such special situations with the audience and this channel that is very new for me. So I'm going to start. So I'm going to start talking a little bit about cystic fibrosis. So this is a chronic inherited disease, and this disease is associated with cystic fibrosis transmembrane chloride that's located in the surface of the cells, and the clinical manifestations associated with this channel is can be seen in different parts of our body. So we can see some difference in the functioning of the reproductive apparatus, in the digestive apparatus, the liver, the pancreas, the salt sweaty, and especially in the lung, we can see the worst outcome because we have infections associated with inflammation. So pulmonary infections, the main cause of morbidity and mortality in CF. 95% of deaths occurs due to respiratory failure. And now we are going into the lungs of this patient. So in the top chart, we can see a healthy lung. So in this case, we can note that the periciliar layer keeps the correct movement of the cilia, and if any pathogen arrives here, it is removed by the correct action of the cilia. The same we cannot find for the lungs of patients that suffers from this disease, that we have a reduced mucus layer, and this traps microorganisms that inhale it and keeps the pathogens here, avoiding the removal by the normal defense and the innate system. So it's difficult to remove these pathogens, and we attract some inflammatory cells for this host, for the site, but we start here an inflammation process that's very difficult for the patient because we have a very tight mucus, and it's difficult the breathing of this patient. So we have a lot of different modifications in this region. So we are going to study in this project 2 different conditions associated with this patient. That is, one of them we know that is the higher levels of sodium chloride, and the other one is the iron release. And let's go a little bit more about the effect of this substance. But first, I'd like to show you the pathogen that I choose to as a model for this study. So Burkholderia cenocepacia is not the most popular, but it is one of the worst of them because this has a huge apparatus of virulence that enables this bacteria to attack the host. So we can find here adenosines, cable pili, system for communication, biofilm that gives this pathogen antibiotic resistance, swimming motility, and a lot of different atypical composition of flagella, for example. So if you wanna to kill a human, you'd like to be a Burkholderia cenocepacia. And this epidemic clone is isolated in Edimburgo, Toronto, and it's called the ET12. So let's look into a special feature that related to the virulence of this pathogen. There is the ability this pathogen has to form biofilms. So in this picture, we can see different stages of biofilm development, and we can see that biofilm avoid the entry of chemical substances and antibiotics, and it's difficult to treat patients that have some microorganisms that are able to develop structures like this, because it blocks the access of the substance. So N-acetylcysteine is a substance that is used a long time ago that has mucolytic properties that enables the treatment of different kinds of respiratory disease. And especially for cystic fibrosis, until this moment, no one could prove its effects. So that's why we are looking into this substance, trying to improve the treatment of this disease. So we are going to study factors associated with sodium chloride and iron. We are going to look into the effect of N-acetylcysteine for this the virulence of this organism. So I'm developing this project because of the importance of this pathogen, the evidence of the modulation of virulence associated with different conditions found in the mucus, the severity of infections, the difficulty of treatment, and the shortage of data related to protein expression in this pathogen. So we are going to explore this condition, trying to find if there is some modifications in the behavior of this pathogen. As objectives to get this point, we are going to try to understand how is this behavior in the presence of this substance. And at first, we are going to look for this using two different techniques, that is diffusion technique in agar, and we are going to look in growth curves to see if the bacteria can grow in presence of this substance at first. So after, we are going to see a special moment at the growth of this bacteria, that is the stationary phase, where we can see the major expression of virulence. And also, we want to verify the impact of this substance on the biofilm that we are using as a thermometer of virulence at this first moment. So I'm going to show you only preliminary results we have obtained. Here we have this table showing all the combinations of conditions we used to analyze the effect of the product. So we use it as a media, reference media, the Luria-Bertani proof, and we use different concentrations of sodium chloride, N-acetylcysteine, and iron from different sources. So the first result that we look into was the obtained by the technique of diffusion agar growth. But by this technique, we couldn't observe difference. That's why I didn't bring this result for you. So now looking to the growth curve, we can observe the bacteria takes an average time of 6 hours to start to grow. And in 22 hours after the growth, the start of growth, it hasn't yet reached the stationary phase that we were looking for. Besides, we have as a reference media the Luria-Bertani, and we can observe that above this line that represents the media we are using as a reference, we notice that iron can stimulate the growth of bacteria, and all other conditions tested are below this line, indicating the ability of inhibit or lower the ability of the bacteria to grow. So the other results we obtained is related to biofilm. So each of these charts represents a different substance we used in this study, and major behavior we can see here is that as we higher the concentrations of the substance that we are looking for, we reduce the ability of the bacteria to develop the biofilm, except in this point for N-acetylcysteine and this point for sodium chloride, that we reverse the effect. So the preliminary conclusions is that the bacteria takes an average time of 6 hours, but we have to extend the incubation period to reach the stationary phase. But also we observed that iron improved the growth, and all the other conditions reduce. And about the biofilm, we could only check 2 conditions where we could find improve a higher expression of this virulence factor related to the condition we used as a reference, that was the Luria-Bertoni group. So we have obtained some protein extracts to analyze the intracellular portions and extracellular proteins that can be expressed during this condition, and this is in analysis. And soon we have these results. And the intention is in the future propose new molecules that can be used to control the infections associated with CF. And this way we can craft this bridge that separates the clinical from the patient from the clinical, and we can reduce this gap. So I'd like to thank you for my program of post-graduation, the Biotrans. A special thank you for my supervisor and for my team from Oswaldo Cruz Foundation, for my husband. And with these results, we are trying with this little piece of information, we'd like to improve the quality of life of these patients that suffer with this terrible disease called cystic fibrosis. I think that each one of us together can construct a better world. Thank you very much for your attention, and I hope you have enjoyed it. Now I think I have some time for a few questions.
Thank you very much, Ivana. That was a very interesting presentation. There's a question for you here from the audience. Would the combination of sodium chloride, NaC, and iron citrate affect biofilm more strongly?
Oh, we didn't test it yet, but it's our intention to combine these 3 substances to obtain protein extracts to analyze it more deeply.
Okay, thank you very much. We're